so complex zeros. This is going to work. It's going to be awesome. You just wait. All right, so today what we're going to do is define and perform computations over complex numbers. And then we're going to use root finding and factoring techniques to break down polynomials with complex roots. So first, we're going to define the imaginary number. The most basic complex number is I, and that is denoted to be, or that's defined, so this little guy here, I, that's defined to be the square root of -1. This is commonly called an imaginary number. Don't think of imaginary number as like made up. It's not made up. It's super duper like it exists, but it's just a thing that folks called it back in the day, which was stupid, but say lovey. Any real multiple of I is also an imaginary number. So some examples of some more imaginary numbers, we could say like 2i. Okay, that's an example of an imaginary number as well. A complex number is a number of the form z equals a plus bi, where a and b are real numbers. A is the real part of the complex number. B is the imaginary part of the complex number. And this is the, like, what really happens here is the real numbers are actually contained in the complex numbers, which is kind of neat. And this basically comes from the fact that b, what if b equals 0? Well, if b equals 0, oh my gosh, this is really hard to do with a mouse, but we're doing it, fam. So if b equals 0, then what happens is you just get the real numbers. Because if b equals 0, then this part here goes away and you're just left with a, and you defined a to be a real number. Now, this was particularly troublesome for me because when I first started teaching, I didn't realize that b could be 0. When I told my students the definition of a complex number, I told them b had to be non-zero. And there was another teacher I worked with who was known for his general kindness, looked over at me one day and said, "You're an idiot. B could be 0 in a complex number." And then I looked back at him and I said, "No, you're an idiot, because if b were 0, then you're saying all real numbers are complex, which is obviously ridiculous." To which he said, "No, you're an incredible idiot. I thought you were just being dumb before, but now I realize you're actually stupid." All of this is very hurtful, and I would never speak to you all that way. I'm just really driving home the point that it's a tough world out there. He said, "No, now I realize you're just stupid. All real numbers are complex because we do allow b to be 0. So long story short, not knowing that b could be equal to 0, that meant I got called stupid. It was hurtful. It hurt my feelings. So a complex number is the sum of a real number and an imaginary number. So you could think of a complex number as like 1 plus 5i. Okay? Or you could even say something like, I don't know, believe it or not, 2i is not only an imaginary number, but it's also a complex number, because what I could do is I could think of this 2i as 0 plus 2i. And then the real part of this number is 0, and the imaginary part of this number is 2. Note, I didn't say 2i. I said the imaginary part of this number is 2. Okay. Now, this, believe it or not, really is just review for this first one in particular, okay? This first one, you're only going to need to use collection of like terms for this one. This guy here is a little bit trickier, but just go ahead and do FOIL, and then we'll work on that in a sec. I'm going to give you a second or so to work on these. Click pause on the video and practice both of these. I'll have the solution up in like a second. All right, so Let's address this one first. So for this guy, what you're going to do is distribute the negative, which is exactly what we did here. And that's how we got these terms. Okay, after we distributed our negative. I'm getting pretty good with this now. So I'm going to go ahead and collect up my like terms. Boom, boom. The 5 and the negative 5 and the negative 6, that's negative 11. 3i and I, that's 4i. Okay, so I should end up with negative 11 plus 4i. Now, for this one here, there's a little bit more going on. So let me just go ahead and skip past the note for now. So we use FOIL, right? So we do 2 times 4, that's how we get the 8. And then negative 2i plus 12i minus 3i squared. Okay. Now, the trick here is this, get out of here. So for this one here, you had this I squared. What's going on with I squared? What is even happening with that? So here's the thing with I squared. And I've got it listed here, but it may not necessarily be obvious to you. So let's start with what I is. So we know I is the square root of negative 1. All right, so now what happens? How do I find what I squared is? Well, okay, just take both sides of this thing and square it. So now what happens here is I squared. Well, the square kills the square root, and I end up with negative 1. So I squared is negative 1. You will need to have that memorized. Okay, you will need to know that. Now, I to the 3rd power and I to the 4th power, you will need to know that just so that you can functionally work through these problems. But this right here, the I to the 3rd and I to the 4th, that's office hour question. But for real, what I need you to know is, get out of my email. So is I cubed, so that you see it written as well, that's going to be negative I. These look crazy. I know. I'm really doing my best here. We're all doing our best here. And I to the 4th is actually just going to be equal to 1. Okay? How did I even... Maybe we are doing our best, but like we can still probably do better than that, right? So I cubed is negative I. Bloop. So let me just be very abundantly clear here. There's nothing special about that anymore. I is just, well, I is I. Okay. So these powers of I, make sure that you have those internalized. Okay, make sure you have those memorized. So we now take I squared and we set that equal to, well, we don't set it equal to. We know it is negative 1. And then we plug that in and we collect up like terms and we end up with this guy. All right. Now, let's suppose I was doing a division here. This division is really, really tricky. The conjugate, we're going to start with what's called the conjugate. So here's some examples of some conjugates. Basically what you do is in the complex number, you take the sign in the middle and you change it. You don't change the sign of the A or the B necessarily. I guess you're changing the sign of the B. Just think of it like you're changing the operation in the middle. So let's suppose I have a number like 5 minus 2i. The symbol we use for conjugation is the bar overhead. So what's the conjugate of 5 minus 2i? Well, I'm going to change the sign in the middle here. And so now it's going to be 5 plus 2i. If you notice, I'm not negating the first term. I'm only changing the sign in the middle. Now, let's do some that are not as obvious. Suppose I had something like 7i. And I wanted to know the conjugate of that is. It's not obvious, but it's going to be negative 7i. It's going to be negative 7i. Now, why on earth is that? Well, here's what I can do. Let's rewrite this to where it's a little bit more obvious. Maybe I could just say this is 0, oh boy, nice 0, plus 7i. Well, now it's clear. I'm going to change the sign in the middle. So now I get 0 minus 7i, which I would never write the 0 anyway. But whatever, we'll just leave it up there now because it's not hurting anybody. Well, no, now we'll get rid of it so you can see it. So the conjugate of 7i is negative 7i. And let's suppose I had the conjugate of negative 15. What's the conjugate of negative 15 going to be? Well, negative 15. Why is that? Well, same reasoning. Let's suppose I said, okay, well, let's rewrite my conjugate. And I said, all right, well, this is going to be negative 15 plus, I don't see an I there, so its coefficient is technically 0, right? And now I'm just going to go ahead and change that sign in the middle. Negative 15 minus 0, I. Well, okay, if I add no i's to it, it's the same as taking no i's away from it, and I just end up with negative 15. Now, why are we doing this? Well, that's a spectacular question. Nobody on this side of the computer. What's so weird is as I'm doing this into the computer, I'm in this office alone, which it's windowless, so there's no windows. There's no there's no contact with the outer world. This is just like a cell that exists in the universe somewhere. And like I'm asking these questions to myself and I'm talking to the computer screen like it's a person. It's complicated, but it might be more uncomfortable for you guys. I'm not sure, but we're doing it. Okay. So anyway, great question. Why are we even worried about conjugates? Well, let's suppose we wanted to actually do this division. Now here's the rub. We can't do division by a complex number. Can't do it. Back in the day, the thing we had to use to do divisions were slide rules. And slide rules could only work with real numbers that were rational. So the notion of taking 2 plus 5i and dividing it by 4 minus i is completely ridiculous. What mathematicians did, though, is they said, how about we just rewrite this division to where, it's a multiplication by 1, and we'll get rid of the complex parts. The complex parts will sort themselves out. Now, here's the way that they did that. Boom, this guy here. If we multiply the numerator and denominator by the conjugate of the denominator, you'll see the denominator knocks out. So here's the original bit. And the denominator here is 4 minus I. Actually, let me really stay true to the notation here. So the denominator here is 4 minus I. So the conjugate of the denominator is 4 plus I. So what we're going to do here is we're going to multiply the numerator and the denominator by 4 plus I. Okay, and so we do that the same way we did the problem previous. Go ahead and FOIL this thing out and then just remind yourself that I squared is -1. And you'll get down to this term here. And then do the same thing here in the denominator. What you're going to notice is these middle I terms should always cancel out. Do yourselves a favor And always write them in such a way that or always write the full thing out. Let them cancel each other naturally, okay? Now, we end up with this 16 minus negative I. Great job doing that circle, Ben. And I end up with 3 plus 22I over 17.